Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So we've got to first of all work out how many parts there are altogether. So we're told that the ratio of red, yellow and green is 3 to 2 to 4. So to work out how many parts there are altogether, we do 3 plus 2 plus 4, which is 9 parts. So there's 9 equal piles of sweets. Okay, but to work out what one part or one pile of sweets is worth, we're going to get the 99 sweets and divide it by the amount of piles, and that's going to be 11. So one part is worth 11 sweets. We're asked to find out how many yellow sweets, and yellow is the middle one, so it's going to be the 2. So yellow has 2 piles of 11 sweets. 2 times 11 is going to be 22, so it's going to be 22 sweets. So when we say y is directly proportional to x, what we mean is whenever x doubles, y will double. Whenever x halves, y will halve. Now we've got this proportionality sign here, and to make that an equals, all we need to do is introduce a k constant to the right hand side. So it's y equals something times x. Now to find out what that something is, to find out what that constant is, what we're going to do is feed in the value of y and the value of x that we have. So we're going to feed those in. So y is 55.3 and x is 7, so it would be 7k. And we're just going to put our lines in and solve this. So it's going to be divide by 7 both sides, and 55.3 divided by 7 is 7.9, and that's what k is. So we're going to rewrite this equation here, this formula here, y equals 7.9x, and that is actually our answer. The important thing to realise in this question is that we know a female has been selected, so we can just basically get rid of all of this part of the frequency tree because it's not relevant, because we know a female has been selected. So there's 29 females altogether, and we're looking for the probability that the female chosen at random picked action. So it's just simply 16 over 29. Just going to write the question out a bit bigger, just so we've got more room. And loads of different methods of expanding brackets. I'm going to do smiles and rainbows. So we just draw a smile, rainbow, and I'll put a little line there to remind me to times it. So we do 5 times 7, which is 35, and it's 7x, so it's going to be 35x, and 5 times 4, which is 20. So our answer is 35x plus 20. So to make estimates from a scatter graph, we've got to first of all draw a line of best fit, which would be something like this. And what we'll do is to find estimate of test score B, given the fact they got 25 on test A, means that we would draw a line up from test A at 25, should be here, and then across, and that's how we'd make the estimate. But look at where that is hitting our line of best fit. It's hitting it here. What do you notice about this position here? Well, all of our data is down here. We don't know whether this trend continues up at this point here. We have no idea. For instance, if you were to plot a scatter graph of height against age, we would see it would increase like that, but that line doesn't continue on forever. Like, you're not a 10-foot giant at the age of 30. You do slowly stop growing, and so we don't know whether the trend continues. So we call this extrapolation. So we say that the data has been extrapolated, and what that means is it is probably not accurate. So when you have the data outside the range of the data, when you have a prediction, outside the range of the data, we say it's probably not accurate. If it was inside the data, we would say it's interpolated, and that's actually quite accurate. So if 2 people liked action but not comedy films, and in total 11 liked action films, therefore there's going to be 9 who also liked comedy, because these two have to add up to 11. Now if there's 9 who liked action and comedy, and 16 who liked comedy in total, if we do 16 take away the 9, that leaves 7. So 7 only liked comedy. It says there's 23 people altogether, so what we're going to do is take away the people who liked action, the people who liked both, and the people who liked comedy. Take all those away from 23, and we're left with 5. So the answers are going to be 9, 7, and 5. To answer this question, we need to know what an equation, expression, formula, and identity is. So the formula is basically an equation but for real world things. So area equals pi r squared. It's where the letters actually mean something. Expression is just algebra without the equal sign. So 5x plus 3 would be an expression. An equation has an equals and it can be solved. So you can find out what x is or find out what a is. And an identity is true for all values of that letter. So an example would be x times x equals x squared. That's an identity because that's true for all values of x. So looking here on the right hand side, we've got 3x plus 2x. But if we imagine x is 10, so 3x would be 30 plus 2x would be 20, 30 plus 20, well that will equal 5x, 5 times 10. And actually this is true for all values of x. And the reason it's true for all values of x is we know that 3x plus 2x, this right hand side here, equals 5x. They're the same thing. Now normally with an identity, it's shown with 3 lines. Now in the exam, this type of question, it won't be shown with 3 lines because that kind of gives it away that it's an identity. But this question is definitely an identity. And you can't solve it because it's true for all values of x. So yes, x could be 10, x could be 1,000,000, x could be 1/3, x could be anything. So I'm going to write the question out. So y equals x plus 15. And we're told that we want to make x the subject to the formula. Now what that means is we want x on its own. What's stopping x from being on its own? This plus 15. So to get rid of it, we do the inverse, the opposite of plus 15 to both sides. Take away 15. So we end up with having y minus 15 on the left hand side, and we've got rid of the plus 15, so we've just got x on the right hand side. So x is equal to y minus 15. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power 4 w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4 w to the power 5. It's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4 w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11v to the power 4 w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power 4s together, and remember with indices, if you times 2 powers of the same base, and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power 5s together, so that makes 10. So it's 121 v to the power of 8, w to the power of 10. With this question, you've just got to know what the different functions look like. So with C and D, we've got quadratic functions. One's a positive quadratic, which is a U shape. one's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that, so we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A. So we notice with these simultaneous equations that the coefficients of the x's are different and the coefficients of the y's are different. But if you look at the coefficients of the y's, they are similar. If we multiply the 4 there by 3, we will get to the 12 there, and we ignore signs. I know it's a minus 12. So what we want to do is multiply everything in that equation by 3. So it's going to be 2x plus 4y equals 20. And we're just going to put our lines in, because what we want to do is multiply everything here by 3. And so we get 6x plus the 12y equals 60. And I'm just going to write that out again, so we can put in our simultaneous equation circles. And I'm just going to write the second equation again underneath, because simultaneous equations are all about working downwards. So I'm just going to show that with these circles here. Now for the coefficients that are the same, which is y, we're going to look at the signs. Are the signs the same or different? Well, if they're the same, we're going to subtract. If they are different, we're going to add. So D in different is the D in add, the S in same is the S in subtract. Well, they are different, one's a plus, one's a minus, so we are going to add. And we're going to find the sum of these. So 6x plus 3x is 9x. 12y plus minus, which is just a minus, so it's 12y minus 12y is 0, which was the whole point of adding, to get rid of those y's. And then 60 plus minus, which just means minus 42, which is going to be 18. Then we just go quickly solve that by dividing both sides by 9. And we get x equal to 3, or 2 even. So x is equal to 2. Now we need to find out what y is. So what I'm going to do is I'm just going to copy out the first equation, but I'm going to substitute in the value of x, which is 2. So we've got 2 times 2 plus 4y equals 20. Again, put my solving lines in, because the first thing I'm going to do is take away the 2 times 2, or take away the 4 from both sides. So we've got 4y equals 16, and then we're just going to divide by 4 both sides. So we get y equals 4. And we can check that with the second equation by substituting in the values of x and y. So 3 times 2 minus 12 times 4 is equal to minus 42. When we draw vectors, the top component of a vector is how far right, and the bottom is how far up. So we're going 4 right and 2 up. So I'm going to just plot a point on our graph, and I'm going to jump 4 to the right. 1, 2, 3, 4. We're going to go 2 up. 1, 2. And our end coordinate is going to be here. So we're going to just join these up with a straight line. The direction is, well, we start at the bottom left and we end at the top right. So the direction is this way. And it says to label it A. So A. We're going to first of all find our target number by multiplying the coefficient of the x squared, which is 2, by the number on its own at the end, which is minus 25. So 2 times minus 25 will be minus 50. And the reason this number is special is because we're looking for two numbers that multiply together to make that minus 50. We're also looking for two numbers that add together to make the coefficient of the x, that positive 5 there. So, looking at the fact that they add together to make a positive, well, any numbers that times together and they end up with a negative are going to be different signs. So we know one of them is a positive and one of them is a negative. And so what I'm going to do is write down all the factors of 50 or minus 50 that are different signs. So we've got, let's have a think, we've got -1 and 50. We've got -2 and 25. We've got -5 and 10. And then we've just got the exact same things but the other way around. So 2 and -25 and 5 and -10. You don't need to write all of these down. If you know what the answer is going to be, you can just go straight there. And we're looking for two numbers that add together to make 5. So what I'm going to do is just put an add here. And we're just going to look through all of these and figure out which one adds together to make 5. Well, -5 plus 10 is going to be 5. So it's this pair here. So it's going to be -5 and +10. And so what I'm going to do now is I'm going to rewrite the question, but instead of a +5, I'm going to substitute in, I'm going to put in the -5 and the +10, or in this case -5x plus 10x. Okay, so I've just changed the +5x for a -5x plus 10x, but those do add together to make +5x, so I've not changed the question. And I'm going to be looking at the first two terms, and I'm going to be looking at the second two terms separately. Now you might be wondering why I've put -5x plus 10x and not plus 10x minus 5x. If you have the choice, always put the -1 first. Okay, it just makes it a bit easier. It means you're not dealing with negatives as much. So looking at the first box, I'm going to put down my bracket. I'm going to factorise it linearly. So we're just looking, there's no numbers that 2 and -5, so it's just an x. And we've got 2x and -5. Second box, well, they both can be 5, so it's going to be +5 on the outside. That would be 2x minus 5. Now notice something here, that these brackets are the same. If they're not the same, you've made a mistake. So we're going to write down the bracket there. And for the other bracket, it's just the bits left over, the bits on the outside. So the x and the +5 will make up that second bracket. So our answer is x plus 5, 2x minus 5, or the other way around. So you could write bracket 2x minus 5, close bracket, bracket x plus 5, close bracket. So we know that frequency density is proportional to frequency over class width. And so looking at this first bar, we've got a frequency of 12 and the class width is 10 wide. So the frequency density you would think would be 1.2, but if we look at it, it's actually 0.4. So we know that we're going to have to divide it by 3 to get there. So our formula is frequency density is the frequency divided by class width divided by 3. Okay, and so to find the next one, to find out what the frequency density is for the next one, we're going to do the frequency, which is 36, divided by the class width, which is 10, and then divide it by 3. And so when we do that, we get the answer of 1.2. And then we're just going to do the same with the next one. Frequency density is going to be the frequency, which is 12, divided by the class width, which on this one is 5, divided by 3. Then when we then do that, we get 0.8. So we're going to plot these on. So our next one is 1.2, so that goes up to 1.2. And then the last one's 0.8. So we're going to first of all factorise the quadratic, and we'll end up with 2 brackets equals 0. And to do that, what we want to do is multiply the coefficient of the x squared and the number and so on together. So we're going to do 12 times the 6, which is 72. So we need two numbers that times together to make that 72. And we're also going to look at the coefficient of the x, minus 17. So we need two numbers that add together to make that minus 17. They need to be the same two numbers. So what we can do is we can write out the factors of 72 and try and find them. Or we can kind of use our head. So it's going to be minus 8 and minus 9. I knew they both need to be negative because they add together to make a positive. Sorry, they add together to make a negative and they multiply together to make a positive. And then just trial and error, just think it through and get minus 8 and minus 9. So we're going to rewrite the expression on the left, but instead of minus 17 we're going to write minus 9x minus 8x, or whichever way around. So we're going to do 12x squared minus 9x minus 8x. I could have done it the other way around, plus 6. We're going to factorise linearly the first two terms, and we're going to factorise linearly the second two terms. So here we can actually divide out 3x from both of them. And we always put the minus on the outside, so it would be minus 2, and that would be 4x minus 3. The repeating bracket is our second bracket, so 4x minus 3, and then the bit on the outside, 3x minus 2, becomes our first bracket, like so. So let's put that back into our equation. And to solve this now, you get both of the brackets equal to 0. So we're going to get this equal to 0. And get our solving lines in. So we're going to add 2 to both sides. Oh, right, 3 there. Add 2 to both sides. And so we've got 3x equals 2. Then we're going to divide by 3 both sides. And we get x equals, and you can write this any way you want, but I'd write this as a fraction to keep the accuracy up. So our first solution is 2/3. And we're going to do exactly the same thing to the right hand side. Get it equal to 0. Get our solving lines in. And we're going to add 3 to both sides. So we get 4x equals 3. And again, divide by 4 both sides. And we get x equals 3 over 4. So our second solution is 3/4. I'm going to start by getting x equal to the 0.847 recurring. And I'm just going to show that with 3 dots. And we want to bring forward everything that's not part of the recurring pattern. So what I'm going to do is I'm going to find out what 10x is. And that's going to be 8.4747. So what I've done is I've just got the recurring pattern after the decimal point. And what I want to do now is bring forward one of the occurrences of the recurring pattern, so the 4 and the 7, just one of them. So we're going to times it by 1,000. We'll find out 1,000x, and so it would be 847.4747, etc., etc. Next, I'm going to take away everything. So 1000x take away 10x, and that's going to be 990x. And then 847.4747, etc. Take away 8.4747, etc. It's just going to be the same as 847 take away 8, because the recurring stuff will just cancel each other out. So 847 take away 8 is 839. And now I'm just going to put my lines in. And so what I'm going to do now is just divide both sides by 990. And so on the left hand side we've got x, and on the right hand side we have 839 divided by or over 990. So as a fraction it's going to be 839 over 990. So for this question, first thing to notice is there's a divide there, and we can actually just write this as a fraction. So 10 plus root 2 over 14 plus root 2. We'll keep the brackets there. We don't need them when it's in a fraction, but it will help us for the next step. So we're asked to transport this or change this into a fraction without a surd at the bottom. And so it's basically asking us to rationalise the denominator. Now, when you have two terms, including a surd at the bottom, we need to do something a bit special with this. And the thing we do is we times it by the opposite bracket. And what I mean by that is if it's 14 plus root 2, we times it by 14 minus root 2. And we've got to do the same to the top. And the reason for that is essentially here all we're doing is we're timesing it by 1, because 14 minus root 2 over 14 minus root 2 is just 1. So we're timesing it by 1, so we're not changing the fraction at all. Okay, let's draw a grid to work out what that will equal. And you can use any method you want. You can use double smiles and rainbows, FOIL, whatever method you have to multiply two such brackets. I'm going to start off with the top. The top is 10 plus root 2 times 14 minus root 2. So 14 times 10 is 140. 14 times root 2 is just 14 root 2. 10 times minus root 2 is minus 10 root 2. And then a minus and a positive make a minus, and root 2 times root 2 is just 2. Now, when you expand surdy brackets, these two and these two will add together. Okay, so we're going to start off with the numbers. 140 take away 2 is 138. And then we'll do the surd. So 14 root 2 take away 10 root 2 is plus 4 root 2. Okay, so the top is going to be 138 plus 4 root 2. And let's do the bottom. And I like these grids because you can see if you've made any mistakes quite quickly with these. You can check your working. So 14 plus root 2 times 14 minus root 2. You'll see why in a second we do the opposite. So 14 times 14 is 196. 14 root 2 minus 14 root 2 and then minus 2. So you can see here now there's a 14 root 2 plus minus a 14 root 2. Let's just cancel each other out to 0. So we get rid of the surd. And then 196 take away 2, which is 194. So we've got 194 at the bottom. Now something we notice here is that all the terms in the fraction are even, therefore we can halve everything. So 138 halved is 69, 4 root 2 halved is 2 root 2, and 194 halved is 97. And so that would be 69 there, and that would be 2, and then that would be 97. So I'm going to first of all just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is one section, we've got 4 of the sections from M to C. So just put like notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. That's why it's a nice, easy way to show that A to M is 1/5 of that distance. Let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. If a to c is minus a plus b, that means a to m is going to be minus 1/5 a plus 1/5 b. Now we're asked for the vector b to m, and we know that that's going to be b to a plus a to m. We know b to a because it's labelled, it's just a. And we know a to m because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 a plus 1/5 b. And so a minus 1/5 a is going to be 4/5 a. And then we've got the 1/5 b. So it's going to be 4/5 a plus 1/5 b. I'm going to start off this question by factorising the denominator of the first fraction. And so we've got 1 over... I'm going to factorise it. Now if you want to see how to factorise it, you can see other videos we've got. I'm kind of assuming you know how to factorise this if you're watching this video. And just keep the second fraction the same. Now you can't add fractions unless you have the same denominator. So if you look at the first denominator, the only difference between the first and the second is that 8x plus 3. So I'm going to times top and bottom of the second fraction by 8x plus 3. Now it helps us to remember that, you know, technically that bottom expression, the x plus 2, is in brackets. So I'm going to just copy down the same first fraction because we're not really doing anything with that. And what I'm going to do is just times top and bottom by the 8x plus 3. 1 times 8x plus 3 is just 8x plus 3. And that should do it neatly. And we've got the 8x plus 3 times the bottom, which will just give us the same denominator. So now the denominators are the same, we can just add the numerators. So it's just going to be 1 plus 8x plus 3, or in other words, it's going to be 8x plus 4. So it's 8x plus 4. And the bottom one is going to be 8x plus 3 and x plus 2. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.